Today we'll look at this familiar concept called energy. Energy simply means the ability or capacity to perform work. So energy has forms, so many forms, but for the purpose of this class, we'll be looking at mechanical energy. And as a matter of fact, we have what we call the conservation law of energy, which we must mention here. We state that energy can neither be created nor destroyed, but rather be transformed from one form to another. It means that no one can create energy nor destroy it. We have forms of energy like heat, mechanical energy, sound energy, and so on. You can only convert from one form to another. So let's look at this concept, energy, mechanical energy. We have mechanical energy has two forms, the potential energy and the kinetic energy. You talk about potential energy when the object is stationary or at rest. When that object starts moving, that potential energy will be converted to kinetic energy. By the time it stops, the kinetic will be converted back to potential energy. So the unit of energy is joules. So we have a problem here to solve. But before then, we know that potential energy is given as mgh, where m is a mass in kilogram, g is the acceleration due to gravity. It's always a constant, and h is the height, or could be vertical distance, and it's always in meters. This acceleration due to gravity is meters per second square. So kinetic energy is given as half mv square, where m is the mass in kilogram and v is the velocity in meters per second. So this we know from the elementary physics that this stands. So we have a problem here. We said that a stone of mass 200 grams is thrown vertically upward with a velocity of 12 meters per second. Calculate 1. The potential energy at the greatest height. B. The kinetic energy on reaching the ground. C. The force applied when it penetrates 5 meters into the ground. And we're given G as 10 meters per second square. So we approach this. Let's do a small sketch. If this is the ground, say a stone is of mass 200 grams is thrown vertically upward. Definitely it will reach maximum height. It will reach maximum height. So that stone has a mass of 200 grams and the velocity is 12 meters per second. And when we said an object is thrown vertically upward at maximum height, v is equal to 0. The reason is that at maximum height, it will rest before it will start coming. So the final velocity at maximum height is always 0. I hope you know that. Okay. And since the object is thrown vertically upward, it's going against gravity. Gravity pulls the object towards the center of the earth. If it is going up, it's going against gravity. In that case, G will be what? Negative. G will be equal to minus 10 meters per second square. So the A part says calculates the potential energy at the greatest height. So at this point, we have A, the potential energy will be equal to M GH. But we don't know H. We know M, we know G, but we don't know H. So we can approach an equation of motion V square equal to U square plus 2AS to help us, which we can write this as V square. We can transform this equation as V square equal to U square minus, because it's going against gravity. That's the reason why the minus here, the G is minus. The G is minus. So we now have minus 2G H, where H is the vertical height. The vertical distance is H, and that is our interest. So we can say that 0 square will be equal to 12 square minus 2 times 10, that's the value of G, times H. So we can say 12 square, 0, equal to, if you square 12, we have 144 minus 20H, because of this, multiply 2 by 10. So what our interest here is H. So we'll take H to the left hand side. So we have 20H is equal to 144. And then H will be equal to 144 divided by 20. And H will be given as 7.2 meters. So we can come back now and calculate our potential energy. We can calculate our potential energy as, therefore, that is the A part. Potential energy now will be equal to mgh, and which will be equal to, the G was given in grams, so we need to convert it. The M is given in grams, so we need to convert it to kg. I always tell you, if you are converting something, a unit to a standard unit, you need to know the relationship. So in this case, 100 grams, 1000 grams is equivalent to 1 kg. 1000 grams is equivalent to 1 kg. And since you are converting from a small unit to a bigger unit, you simply divide 200 by 1000, and that will give us 0.2 kg. So in this case, where M is equal to 200 grams, which is equal to 0.2 kg, and H we calculated to be 7.2 meters, and G is 10 meters per second square. So what you do here, just to substitute. So by the time you substitute, we have PE to be equal to 0.2 times 10 times 7.2, and by the time you work this out, you have 14.4 joules. You have 14.4 joules. So that is just the A part. The B part, calculate the kinetic energy on reaching the ground. There are two ways to this. We know kinetic energy is equal to work done, and work done is force times distance. So if the object has potential energy of this, if it's moving, this potential energy, this value will be converted to kinetic energy. So without, if it's a distance or objectives, you don't even need to do some calculation here. Since you know that work done is equal to kinetic energy. Therefore, potential energy is equal to kinetic energy. But let's do the calculation. Kinetic energy is given as half mv squared. Because with this, already we know that the answer is 14.4. But let's calculate it. This is equal to half times 0.2 times the speed is given as 12. That will be 12 squared. So you have half times 0.2 times 144. So by the time you multiply this out, it will still give you 14.4 joules. And then the last one is the force applied. The force applied when it penetrates 5 meters into the ground. The kinetic energy, applying the principles of conservation of energy, potential energy converted to kinetic energy. So that kinetic energy on hitting the ground, it will now be converted back to potential energy. So what we are calculating is the force. We want to calculate the force. The kinetic energy is equal to work done. And we can say that kinetic energy is equal to force times distance. So we have known this. We have known this. So we can calculate force. This kinetic energy is what we calculated as 14.4 equal to force times the distance is given as 5 meters. So we can say that F is equal to 14.4 divided by 5, and that should give us 3 newtons.